Hi everyone, I'm really excited to be here today. So today I'm going to talk about Unified Data Frame API for own backends. So I'm part of Bonchon Data. Our company invests a lot into open standards or open data format for data systems. So we contribute to and maintain projects like Apache Arrow, Ibis, and Substrate. So a lot of people ask us, it's like, okay, you can't make money from open source. So like, how do you make money? So another area of our effort is in our commercial product, which is a GPU native query engine called Theseus. So data processing turns out to be very natural parallelizable, which makes a lot of the workloads ideal for GPUs. And we have found that for a lot of companies, by moving their data processing workload from CPU to GPU, not only they can save a lot of money, but they can also speed up their workload a lot. So here's a benchmark. But it is not the focus of the talk. So basically, our sweet spot is for companies that have a lot of data, like over 30 terabyte of data. That's when you see the most benefit from TCS. Okay, so because our talk today is on unified interface, and whenever this topic comes up on like Reddit, Twitter, LinkedIn, there's always somebody who posts this XKCD CD comic because basically it's really hard to build something that's like standardizations of anything. However, I hope that I can convince you through this talk that it's not only doable, but we have had a lot of success, not just with Ibis, but like with other projects like Apache Arrow. Okay, so one thing that I hope we can all agree on is that data is extremely important, especially with the rise of AI in recent years. So we have AI data for many use cases, and the diverse data needs had led to a lot of diversifications of data systems. So one of the divergence in data is what you think of like as a local and distributed data. So for a lot of people, when you do experimentations, you want to think quick and dirty. So you run experimentations on the local machines, the laptop. But then when you deploy the systems, you have to like, move them to like some remote distributed engines like RAID, BigQuery, Spark. Um, and then another divergence that we saw that very recent, not that's quite recent, maybe like about like 10 years ago, is the rise of streaming. So now we have the batch system and streaming systems. And a very common pattern we see, especially in machine learning use case, is that like for training, you would train the systems, you should train the model using batch data, but in productions, then you would use streaming data or like real-time data to serve the models. And there's a lot of mismatch. We see a lot of pain caused by the mismatch between batch and streaming. For example, very interesting report by Pinterest where they found out that for streaming, for a lot of their operations, is like 90% of them actually like inconsistent with the results they would have got from like batch systems. So another divergence, probably the newest one, is with the rise of GPU. So now we have like CPU infrastructure and GPU infrastructure. So a lot of data science tooling are not naturally runnable or like are not built for GPUs. For example, like NumPy, Pandas, um, or even like scikit-learn are not built for GPU. So we've seen a lot of effort into making the system work on GPUs. For example, NVIDIA has the whole Rapid AI team so that it can make like things like Spark run on GPUs with a lot of success. And also, for example, like because Pandas doesn't run on GPUs, we have a lot of like dropped-in replacement like DAS that runs on GPUs. And of course, our team is building TCS so that it can make data workloads run very well on GPU. So like all of this divergence and the diversity of data systems leads to like several big challenges. So first, like it takes a lot of effort to build a custom data system. So we see many companies, not just large company, but also like medium-sized company having to build data systems from scratch. So you see probably seeing like Meta, Netflix on build their own data systems. And it's not like it's not just big company, but a lot of smaller companies as well. So we see a lot of like code rewriting and translations. So I can't really see anyone here, but I wonder, not sure like by show, like how many of you have ever had to translate the code from Panda to PySpark, and it's quite painful. So we've been so like so when you had to like move data across different systems, then so the challenge of runtime inconsistency. So for example, you have some things that run really well locally, but then things just like don't run well, just don't quite work remote. So we see a lot of like tests. We've seen a lot of people complaining about inconsistency when moving different across different data engines. And of course, there's another issues of like vendor lock-in. So no matter how cool the system is, eventually they're gonna become outdated. So if you build a system that's so tied up with some engine, and it's make it very hard to like move onto another platform later on. So because of that, this last year as VLDB, there was a very there was a paper published jointly published by Meta, Databricks, Vonchon, and so Sundek about about composable data systems. So the idea is that even though data systems are complex, they are like can have many different data systems. But the core, they have very similar components. And if we can standardize these components, it will make it a lot easier for people to plug and play different components to create their own data systems. So here's the outline from the paper. So at the top, we have this thing called like the interface. So you can have like SQL or non-SQL. So in case non-SQL, like a lot of people use the frame API so that you can like interact with the system so that people can write queries to interact with the data. And then after that, we have like the intermediate implementations like IR so that it can be translate the query into the query optimizer such as like Apache Gunsight or Orca, and then again it can compile into the execution engines which can be like Spark, Ray, or other engines. So one thing that like I'm not sure you can see my mouse, but one thing that the paper didn't really go deep into is that like standardized memory format for data. So for different engines, data query engines which communicate with each other, there needs to be some certain standardized memory formats that everything can understand, and that's what Arrow was designed to be. So today I want to focus mostly on this layer, which is a unified interface across different query languages. So we can think of like what we are building is something to sit on top of different interfaces. So we call our project Ibis, and when we set out to design Ibis, which aimed to be the unified data frame interface, we thought of like requirements, like what would this unified API need to do for it to work. So first, like this API has to be extensible to a wide variety of backends. So there are many different backends for different purposes, right? Like we talk about like batch streaming, local distributed CPU native, GPU native, and this API will have to be to support like most of these engines, or like at least like the ones that users care about. And the second is that it has to give the native performance because we sit on top of these different engines, right? Like so, if people write code in this API, it wouldn't have to run just as fast as if they had written the code in the native, like in the backend. And the last is that it had to be like give consistent results across frameworks, right? So because say if you write code in this API and run it on pandas, and then again it run this on Snowflake, and if it give different results, that could be like pretty alarming. So that is what we set ahead in mind when we built out these engines. So what we created was like Ibis. And Ibis today support like over 20 different engines, like including across both SQL engines and like data frame engines, as you can see on this in this image. So the way Ibis works is that like you can write code in Ibis API, and then we compile into the intermediate implementations, which were like relational expressions, which is SQL equivalent. And then from there, like, depending on how or where you want to run the query, it will compile into the backend. So for example, you write the code and say, hey, I wanted to run it using Polars. We'll compile it into Polar. And then if you want to run it on Snowflake, we compile into Snowflake SQL. And similarly, if you want to run it in Flink, we can compile it into Flink SQL. So it makes it very flexible. You can swap between different engine in just like one line of code. So I can show this here. So one of our team members builds this really cool tool. So for example, you can see the code across different engine, right? So here is when you connect to a DuckDB table, and here's the code. Or if you want to connect to Flink, it's the same code. If you want to connect to Spark, so you just change the engines, and the code is very, very similar. So this means that by using Ibis, once you can just support multiple backends out of the box. And the second, like if you want to change the backends, for example, from local to like remote, you can just do so by just changing one line of code. Cool. So like this, so here we also have a QR code. If you want to play around with it, you can click on it. Or you can you can scan it. So the first requirement, right, like is the API has to be extensible. So because we have supported 20 plus backends, we are pretty confident that our API is fairly extensible. So focus is that we want to maintain like these different existing backends, right? So when we say that we support a backend, it's not just there's two aspects. One is coverage, and the other is performance. So the API has to be able to cover like our unified API has to cover like most or like all those operations that's native API can do. And the other is that the performance has to be pretty well. So I can see on here like this some of the PRs that we merged or like the issues recently is that we continually adding a lot of functionality. So for all the backends we support, we have pretty good coverage. But like these different backends will also evolve over time, right? So we need to like keep up to date with those and keep adding new features. And also, of course, there's a lot of like requests for new backends, and we also like slowly adding them as well. So first of all, like Dremio is a great company, and we do want to support Dremio, and hopefully we can get you as soon. Another requirement for the unified API is that it has to run just as fast as a native performance. So we've done a lot of tests, a lot of benchmarks to make sure that like by just using Ibis, the user don't lose like performance. So first of all, here you can say this like by using Ibis on top of Polars, the performance is just very similar to like using Polars. And using Ibis plus Data Fusion is very similar to like using writing code in Data Fusion directly. And there's a lot of benchmark with other frameworks that we use as well. So in this case, we also try to benchmark with pandas, and pandas just run out of memory. So on a side note, I'm actually really surprised by how pandas is still so popular, because given that there's so many different alternatives that are not quite memory hungry and a lot more performant, and it's equally easy to use. I do think that's like for people who are still using pandas, do consider using like one of the many other data frameworks. So you can see more on the link here is some if you want to read more about the performance benchmarks that we have done. Another aspect of the requirement of the unified API is that it has to be consistent across backends, right? So at this point, we sort of done a lot of tests to make sure that the results are like consistent. So here's just like a screenshot of some of the tests. Some of the tests, some of the tests you can go and choose /ibis/backend/test. So we have both tests across a framework, and we also have tests for each individual backend. And we also run each PCH test so that to make sure that like our like Ibis API can pretty support workloads across different backends. So it's been a lot of fun maintaining and building Ibis. So just want to go into a little bit of one functionality, one features of Ibis that people like. It's like deferred execution. So without it, if you want to do local executions, like using like connect your remote engines, usually have to do connect. You get you grab a table, and basically like something like pandas would actually like read the entire table in, even though it's just one column or two column, which make pandas run out of memory very quickly. So for us, we do a little bit of like we have a different approach. So like when you connect your remote table, we only get the table schema, and then we generate we only execute when you actually do the queries. So that you don't have to like lose on the so that we're going to read and execute the data that you need for the executions, and it makes things a lot easier to run. So now let's get back to the original questions. So is it possible to create some standardizations of API? Because everyone tries to standardize things and even up with like an extra standard instead of like an extra API instead of like a unified standard. So I would argue that standardizations is inevitable. And we have seen that with a lot of products, but I think the closest thing we've seen is like Apache Arrow. So Apache Arrow was created as a standardizations of data in memory data format. And today it has been adopted by pretty much all the major data engines out there. And it does make a lot of things easier when there is some standardizations going on. Um, for for Ibis, we also are seeing similar. And because of like Ibis, and because of like, I do believe incentive, right? We can't force people to do anything unless they see the reason why they should be doing it. And we do see this like for users, there's some clear value propositions for them to move on to a more standardized API. So here's some of the incentives I've seen people using Ibis to achieve. So one thing is just like it makes it a lot easier for you to use the same code for both experimentations and deployment. So you can write the code, you can experiment with anything locally, and after that, once you're happy, you deploy to Snowflake. It's pretty easy. And one use case that I think that people are using Ibis for, which is something we did not plan for initially, but we find pretty helpful, is that now we can actually run tests across different engines. So I was catching up with a friend recently, and he was complaining about, so he's saying something like, "Oh, we have a lot of different workloads across different engines, and for me, if I want to like create a test end-to-end test, I had to do a lot of manual glue work." So using something Ibis, you actually go to Ibis blog, and there's a tutorial on how like you can orchestrate or like orchestrate end-to-end tests across like DuckDB and Snowflake. So like we will do a lot of glue work for you and makes it a lot easier for you to test our data pipeline end-to-end without extra like with minimal overhead. And of course, we also like do a lot of work to like unify batch and streaming. So streaming data has become like pretty common. So we see this like many companies today, not just have like uh, tables, but also like data coming in from like Kafka, Red Panda, and to support like streaming has a lot of functionalities that like batch, like syntax, like batch doesn't support. First of all, like windowing syntax. So one of the first thing our team did. So by the way, I joined Vonchon Data after they acquired Claypot AI, and one of the first thing our team did was to contribute the streaming support to Ibis, and we extended the SQL syntax, which is support like a lot of like windowing syntax that streaming has. So I'm pretty proud to say that like Ibis is one of the first, it's not the first, but like one of the more popular one out there to support streaming and bash pretty well. And also like another big use case that we see for Ibis is like from a data platform. So imagine that you are a data platform that support a lot of users. And each of the users may have their own backend. So occasionally you might have people request like, hey, can you support this backend? Can you support the other backend? And it can take a lot of effort to like support each individual backend. So by adopting Ibis, you can just like support like all the backends that Ibis support out of the box. And also another use case that we also got asked a lot is like using Ibis to benchmark different backends. So imagine you are building a new data system, right? And you don't know which query engine to use. So you can also look at different benchmarks, but so benchmark like might not cover all the queries you want to do. So what you can do is that you can write your own like set of queries you want to test for, and you can use Ibis to like run on the backends you care about and see like, which one achieve like the best performance. And because Ibis queries can just perform just as well as the native code, it's a pretty good indication like for you to choose like which query engine is best for you. So here an example of someone who used Ibis to benchmark different backends, and it seems like that person seemed pretty happy because you can just do so with like one line of code. We also like do a lot of benchmark internally. So here's another example of like I'm not sure you're familiar with the Billion Road Challenge recently, and we found and we sort of like did it in Ibis just for fun, and we could like do one. It's very easy for to like benchmark like to be polars and data fusions like using Ibis. So we're also like dealing, and it's because of all these cool use cases, we're actually seeing a lot of adoptions recently. So Ibis is one of the weird project because it was started like pretty long time ago. It was in like 2015, 2016. And it was started by Wes McKinney. So he's a creator of Pandas. And back in 2013, Wes already discovered like Pandas didn't scale very well. And Wes wanted to build the next generation's Pandas. And Ibis was a project. However, Wes at the same time wasn't so started Apache Arrow. And a lot, you can see that for a long time, Ibis didn't see a lot of growth and development because no one was looking at it. So our company, Bonchon Data, started picking up and maintaining, developing Ibis in around like 2022, and you can see that from then we've seen a lot of consistent adoptions from quite a few companies. Um, so one big question that we also get asked a lot is just like, okay, this provide a data frame API in like Python, but how about SQL? Um, Another person actually told me that he thinks that the biggest challenge of these adoptions is that people just don't want to use data frame API and just don't want to use Python. And I can certainly like see some reason to it because I do think that's like a lot of people just like SQL, and SQL is pretty versatile, right? Versatile. And so I come from a machine learning world, and usually like a lot of data scientists and machine learning engineers, you should really like Pythons and didn't know a lot about SQL, but we are seeing a lot of adoptions in SQL from like machine learning and machine engineers and data scientists. However, like SQL also has a lot of challenges, and we actually like have pretty long. We can have a long discussion about it because for one thing, like what does it mean to like what does SQL exactly what does SQL mean? Because like there are many different SQL flavors, and like every backend can be like slightly different. And we know that because we support many different backends, it's always found like a little bit different in like, every different backend. But however, regardless of like which one is better, like SQL or data frame, I do believe that they are both like great for different use cases. Ibis actually support both. Like you can actually write SQL within Ibis as well if that's something you really want to do. Okay, that's it from me. Thank you so much for attending my talk. Here is the GitHub link for Ibis. Want to check it out. I'm also on Twitter and LinkedIn if you want to follow up and ask any questions.